Welcome to this YouTube channel. In this video we will talk about the top 10 energy sources of the future. So before starting this video, like this video and subscribe to our channel for future updates. The latest assessment from the UN Intergovernmental Panel on Climate Change, IPCC, which was released in November, does not portray a particularly rosy image. The scientific community's most forceful call yet for governments around the world to get serious about cutting greenhouse gas emissions warned that failing to reduce emissions by 40 to 70% globally by 2050 would have disastrous effects for the environment. Here are some of the most cutting-edge ideas that have the potential to fuel our future. Number 10. Carbon capture and sequestration. Carbon capture and sequestration, technologies that allow for the scrubbing of carbon from power plants for storage in subterranean reservoirs, may finally be coming of age after years of trial and error, despite the fact that it is not a power-producing technology. It is hoped that it will serve as a catalyst for other carbon-emitting technologies, such as biomass or algae-based biofuels. Because organic fuels absorb carbon from the atmosphere before converting it to fuel, this is the case. Number 9. NextGen nuclear power. Since the Fukushima nuclear plant tragedy in Japan in 2011 following a severe earthquake, the nuclear power sector has been working on safer technology solutions. Nuclear reactors dozens or even hundreds of times smaller and more widely distributed have been proposed so far. Consider nuclear power facilities the size of warehouses that serve neighborhoods rather than entire cities. Some of the designs for these modular reactors include passive safety systems to limit the risk of a radioactive discharge like the one that shook Japan. Nuclear reactors will also be built offshore, similar to the floating platforms used by the oil and gas industry. A Category 5 hurricane would be no match for these. Furthermore, because the reactor cores would be buried beneath the platform, a constant supply of cold seawater would be available to cool the reactor core in the event of a power outage. Number 8. Nuclear fusion. Nuclear fusion, which promises endless carbon-free power without producing harmful nuclear waste, is the holy grail of clean energy generation. Fusion reactors could provide a lot of energy with little environmental impact if scientists can figure out how to manage the same kind of atomic reaction that occurs at the sun's core. While the technology is still 30 years away from maturity, Lockheed Martin, a defense contractor, has made strides. Its scientists devised a tiny fusion reactor design in October that may potentially fit in a tractor trailer and generate 100 megawatts of power. Within 5 years, the company intends to have a functional prototype and a commercial version. Number 7. Offshore wind. Wind power is expected to become widely used in the next 25 years, thanks to developments in turbine blade designs that borrow from aeronautics technology to extract the most energy from each gust of wind. Wind turbines will increasingly be located offshore, where countries such as Denmark are already demonstrating to the rest of the world the benefits of offshore wind energy. Wind power currently provides a third of the country's electricity and is predicted to supply 50% by 2020. Offshore wind farms, such as the 111-turbine on-Holt farm, which was finished last year, generate 1.27 gigawatts of power, enough to power over 1 million homes. Intermittency is less of an issue because offshore wind resources tend to blow stronger and more consistently than onshore facilities. Number 6. Geothermal. Geothermal energy is projected to explode in the coming decades as scientists discover a commercially viable means to capture energy deep beneath the Earth's crust. Researchers in Iceland have been drilling straight into volcanoes for several years to access very hot water and magma reserves, with the goal of someday converting these high-temperature resources into significantly more productive geothermal power stations. The goal is to produce sophisticated technology that can be exported within the next 10 years. If the research pays off, it may soon be able to tap considerably hotter geothermal resources around the world that can create 10 times the amount of electricity currently produced by geothermal plants. Researchers predict that vast reservoirs of heat energy are attainable just 1,000 meters below the seabed at the Juan de Fuca Ridge off the coast of Washington state, making drilling geothermal wells offshore a possibility in the future. Number 5. Space technologies. For the time being, space-based energy technologies such as extracting hydrogen from the moon to power fuel cells on Earth or circling solar arrays that absorb all-day direct sunlight and beam the energy back to ground stations through radio or microwaves remain science fantasy. NASA and the Naval Research Laboratory of the United States are both investing on technology that could be marketed in 25 years. The ongoing private space revolution, which has seen businesses like SpaceX reduce the cost of transporting goods into orbit, bodes well for future space endeavors. Solaring, a startup based in Southern California, has signed an agreement with Pacific Gas and Electric to provide space-based solar power by the end of the decade. Keep an eye out for updates. Number 4. Solar fuels. Scientists have long been enthralled by the prospect of transforming sunlight, water, and carbon dioxide into usable chemical energy that can be stored for long periods of time, much like gasoline. Solar fuels are made by splitting carbon atoms from carbon dioxide molecules that have been taken from the atmosphere. Then, by separating hydrogen atoms from water, you may combine carbon and hydrogen to generate hydrocarbons, which are the same chemical entities that make up today's fossil fuels. If scientists can scale up these chemical reactions utilizing solar energy as a catalyst, they'll be able to convert the sun's energy into a storable medium while also recycling carbon dioxide from the atmosphere into useful chemical fuel. Although the science isn't quite there yet, scientists from Harvard's Nochera Lab, MIT's Grossman Group, and the University of North Carolina's Energy Frontier Research Center have made significant progress in the last decade. Number 3. Algae Biofuel. Consider the parallel with solar power if you're still unconvinced about naturally occurring strain. While ultra-efficient solar cells are becoming more widely available, the most efficient solar cell does not always imply the most cost-effective solar installation or the largest range of applications. Consider the difference between low-efficiency organic solar cells and their high-efficiency silicon counterparts, and you'll get the idea. EHE and algal systems have taken a comprehensive, energy-efficient approach to algae biofuel production, transferring that concept to algae biofuel production. While the new algal biofuel system may not have the most effective strains for biofuel production, it is a problem solver that takes a liability, in this case, municipal wastewater, and turns it into a source of revenue. Number 2. Flying wind farms. Alteros, which was founded by grads Ben Glass 08, SM10 and Adam Rain MBA10, has created the world's first commercial airborne wind turbine, which uses a helium-filled shell to float as high as a skyscraper and harvest the stronger, more consistent winds available at that level. The buoyant air turbine, or BAT, technology, which has been proven to produce twice the energy of comparably sized tower-mounted turbines, is presently being prepared for commercial deployment in rural Alaska. The BAT hovers 1,000 to 2,000 feet above ground, surrounded by a spherical, 35-foot-long inflatable shell constructed of the same heavy-duty fabric used in blimps and sails, where winds are 5 to 8 times stronger and more consistent than winds at tower level, roughly 100 to 300 feet. Number 1. Hydrogen, fuel cells. A hydrogen aircraft is a plane that runs on hydrogen fuel as a source of propulsion. Hydrogen can either be consumed in a jet engine or another type of internal combustion engine, or it can be utilized to power a propeller using a fuel cell. Unlike other planes, which store fuel in the wings, hydrogen planes often have hydrogen fuel tanks built within the fuselage. Large commercial hydrogen aircraft could be produced by 2020, according to research from Pennsylvania State University in 2006. Butte will probably not enter service until closer to 2040. In the near future, there has been an increase in interest in employing fuel cell airplanes as personal air vehicles. The European Union's Cryoplane research project evaluated the technological feasibility, safety, environmental compatibility, and economic viability of using liquid hydrogen as an aircraft fuel in collaboration with Airbus and 34 other partner firms. This was completed in the year 2002. As of 2021, ZeroAvia is working on a fuel cell-powered aircraft that will be capable of carrying up to 20 passengers for 350 nautical miles. A 100-passenger turboprop, a 200-passenger turbofan, and a futuristic design based on a blended wing body were exhibited by Airbus, with deployment planned for 2035. In operation, hydrogen aircraft with a fuel cell design emit zero CO2 but not NOx, whereas aircraft with hydrogen as a fuel for a jet engine or an internal combustion engine emit zero CO2 but not NOx. What do you think about this video? Do let us know down in the comments section below. If you enjoyed this video and want to hear from us again, be sure to hit that subscribe button before you go.